I am Anil Kumar. Welcome to my series on quadratic expressions. We'll take up factoring trinomials in this particular video. Here are the topics of our interest. We'll first understand the basic concepts to factor trinomials of the form ax squared plus bx plus c. We'll model the situation, break up the middle term with sum and product and then factor. And then we'll have a couple of practice questions to factor trinomials. We'll take some with common factors. We'll factor with fractions. And we'll also factor when two variables are involved as shown here. Now factoring may also involve perfect squares. We'll take up an example. We'll have a communication and question. And we'll have a communication and application question followed by an extended question. Now here is a free offer which I am giving to all my students during this tough time of COVID-19. Students are trying to learn from home. We have a very special offer for you. We are going to guide 10 students free of cost, and regularly they can be in touch with us to master skills in mathematics. Only thing which you need to do is to send me an email on the address given here. So send me an email on this address. Do take permission from your parents. Write me about yourself. What is your objective and why do you think we can help you? That will help us to decide whom to offer this particular curriculum free of cost. Now let's begin with the concepts of factoring. As we have done in earlier videos also, here again we'll see how expanding and factoring are related. So the basic concept to factor trinomials of the form ax squared plus bx plus c could be shown here. Let me take any example. Let's write down, let's say 2x plus 3 times x minus 5. Now if I want to expand this, then what do I get? 2x times x is 2x squared. When you multiply by minus 5, you get minus 10x. Multiplying with 3 will give you plus 3x and minus 15. As you can see, the center terms can be always added. They are the like terms. So when we add them up, what do we get? We get 2x squared minus 7x minus 15. Now, if you are given 2x squared minus 7x minus 15, you can get the result from where it came. Definitely, it came from 2x plus 3 times x minus 5. So the reverse process is factoring. Is that clear to you? So you're all very familiar with this part, which is expanding, right? Now what we are doing is factoring the reverse process. So you'll be given a trinomial, means we have here three terms. And what do we get is a factored form, product of two. So which means product. Do you see that part? So three terms which are in the form of sum or difference can now be written as factors. So that is what we will be focusing on. Let's look into a model to visualize the situation. So we have algebra tiles here. One side of it could be written as x plus 3. The other side could be written as 2x, these are the 2x tiles, plus 1. Now when you multiply them, what do you get? Let me rewrite here. So we have 2x plus 1, and we are going to multiply this by x plus 3. When you multiply, you can clearly see the result, which is x squared. There are two of them, right? So we get 2x squared plus, these are your x's, 1, 2, 3, 4, 5, 6, and 1, 7. Plus the units 1, 2, and 3. That is what you get. Now, in general form, we are writing a trinomial as ax squared plus bx plus c. Now to factor, you will realize how we got these terms. Well, we got a term 3 by multiplying 1 and 3. So when you multiply 1 with 3, you get 3. The center term on the other side is the sum of two outer and inner products. So here 2 times 3 is 6 plus 1 times 1 is 1. When you add 6 and 1, you get 7. The center term is the sum of these two. So basically what we need to do here is we need to split this b in two parts. Let's call them as p and q. So sum of these two should become b. So we are looking for two numbers p and q whose sum is b and whose product is a times c. So product of p and q should be a times c. Now in this particular case, you can correlate to the situation. We have 6 plus 1, which is equal to 7, and 6 times 1, which will give you 6, which is 2 times 3. Does it make sense to you? So this is the concept of factoring. So let's now take a few examples. Basically, what we will do here is we'll split the middle term to get the factored form. So the first question here is, break up the middle term with sum and product. Question 1, factor 3x squared plus 7x plus 4. So the two numbers which we are looking for are p and q, where the product of p and q is a times c, which means 3 times 4, which in this case is 12. And the sum of these two numbers, p and q, should be the center term 7, which we need to split into 2. Now what combination can work for you? Well, clearly, as far as 12 is concerned, we know 4 times 3 is 12. And when you add them, you do get 7. So it works for you. So we'll split 7x in terms of 4 and 3. So first let me rewrite the function itself, which is trinomial is 3x squared plus 7x plus 4. Now we will split 7 into 2, and what we are going to get is 3x squared plus 4x plus 3x plus 4. And now we can group them and then factor. So if you look into the first group, what is common? Well, x is common in the first group. Taking x common, we get 3x plus 4. In the other group, nothing is common, that is 1 is common. We are left with 3x plus 4. And now 3x plus 4 is common, so we can write this as 3x plus 4 times x plus 1. Does make sense to you? So that is how we are going to do. So we copied the question and we wrote the 7x as 4x plus 3x, kind of split 7 into 4 and 3 simply because the product is 12. And then we did group factoring, and thereby we got the final result, which is 3x plus 4 times x plus 1. So I hope this is clear. We'll do a few more questions to practice. Here is question number 2. You need to break up the middle term. Use sum and product to find the factored form. I'd like you to pause the video at this stage, answer this particular question, and then look into my suggestions. Right? So I'm just taking my time to copy the question here so that you could go ahead and work on it. So here we're looking for two numbers p and q whose product should be a times c, means this 5 times 3, which is 15. And the sum should be what? The sum should be the center term, which is in this case minus 8. What could be those numbers? 5 and 3, both negative, right? So if both are negative, your product will be positive and the sum will be negative 8. That works. So we're going to split the center term, which is minus 8x, with minus 5x and minus 3x. plus 3. So that is how we could write our trinomial. Now we have 4 terms. Let us see what is common between the first group and the second group. In the first group, we could take 5x common, and we are left with x minus 1. In the second group, 3 is common. We are again left with x minus 1. Since x minus 1 is a common factor, it can be factored out, and you get your final result, which is 5x minus 3. Perfect. So that is how we are going to factor the trinomial where the leading coefficient is not 1. Perfect. Let's take up one more question here. Let this be a test question for you. You can now copy this question, find the solution, and then match with my solution. The question is 3x squared minus 7x minus 6. You need to write 7 into 2. Split it into 2. How are you going to get those two numbers? Well, the product of those two numbers should be 3 times minus 6, which is minus 18. And the sum should be how much? Minus 7. The two numbers which can help you is 9 and 2. Bigger number should be negative since we have addition of minus 7. So we'll write this as 3x squared minus 7x as minus 9x plus 2x. That gives you minus 7x. And now we'll do group factoring. The first two terms, 3x is common. We are left with x minus 3. And here 2 is common. We are again left with x minus 3. If that is not the case, then you cannot factor, or you have done something wrong. So this is a good point to check. You should always get this common factor. Otherwise, something went wrong. X minus 3 is now a common factor. You're left with 3x plus 2, which is your answer. Is that clear to you? So with this, we have understood many examples. We'll move on to a different type of factoring. This is again a trinomial, which is, in this case, you need to factor 8x squared minus 26x plus 20. Now, as you see, all are even terms. You can take something common, which is 2. So first thing is, let's take whatever is common. Taking 2 as common factor for all the three terms, we get 4x squared minus 13x plus 10. Now we have a trinomial where a value is 4. We can utilize the product and sum technique. Product of P and Q should be A and C, which is 4 times 10 or 40. And the sum of P and Q is the center term, coefficient of x, which is minus 13. How can you get two terms? Well, 8 times 5. So minus 8 and minus 5 can work for us. When you add, you get minus 13. So we'll do that and continue. So what we get here is 2 is a common factor. 4x squared is the first term. The leading coefficient is 4 in this case. For the trinomial, minus 13 will be written as minus 8x minus 5x, and we have plus 10. Let's group factor them. So 4x and 8x, 4x is common. We are left with x minus 2. Minus 5 is common. We are left with x minus 2 once again. So now we can take x minus 2 common. 2 is already outside. X minus 2 has been taken as a common factor. You are left with 4x minus 5, which is the final result. Is that clear to you? Well, at times you could also use square brackets here so that you avoid the confusion of too many brackets of same time. So that is just a suggestion. Now let's take up next question, which is 5. We have 10 questions in this particular video, which will give you good practice on the topic of factoring. This will be followed by a midterm test. The question here is common factor combination. That is what we'll try to do. Question number 5. Factor 2x squared x minus 1 minus 3x times x minus 1 plus x minus 1. Well, clearly, x minus 1 is a common factor. So I'm not writing the question this time. I'm straight away writing the common factor x minus 1, and within square brackets, I'm writing 2x squared minus 3x plus 1, the trinomial. Now, leading coefficient is 2. Let's find product and sum. Product is 2 times 1 and the sum of the two numbers is minus 3. The combination which can result is minus 2 and minus 1. So we'll split the center term with minus 2 and minus 1. So we get 2x squared minus 2x minus x plus 1. Let us take the common factor between the terms and complete the factoring process. So 2x squared minus 2x, 2x is common. We are left with x minus 1. Taking minus common gives you x minus 1. Sometimes you may get stuck here, thinking as if now what to do. If you take minus common, you get x minus 1. Do you see that? So you get x minus 1 as a common factor. So we have 2x, let me write down x minus 1 first, which is a common factor. That is a good practice. So we factored out x minus 1, we are left with 2x minus 1. And when you open this, we have two terms with x minus 1. So we could write this as x minus 1 whole square times 2x minus 1. Perfect. So that is our result. Let's take question number 6 now, which is factor trinomial with fractions. That will be interesting. So let me rewrite the question here, question number 6, which is half of x squared plus 3 by 2 of x minus 5. Can you group factor something? Yes, half is common. So let's take half common. You are left with x squared plus 3x minus 10. You have to multiply 5 with 2 minus 10. And now again, let's look for product and sum. We have a trinomial. We're looking for product of two numbers to be 1 times minus 10, so it is minus 10. And we're looking for sum of two numbers as plus 3. Well, the two numbers could be what? 5 and 2. Where 5 is positive and 2 is negative, that will give you a negative product and positive sum. So we'll change. We could actually directly write down the answer this time, since the leading coefficient is 1. So we can write this as x plus 5 times x minus 2 as our result. So we get our final answer as half times x plus 5 times x minus 2. Is that clear to you? Perfect. Now let's take up an example where we have two variables. So in this case, we have x and y, two variables. Question number 7 for you. Factor 3x squared plus 8xy plus 4y squared if possible. Now this term, if possible, is very important. You cannot really factor all the trinomials. You should have a combination of product and sum, right? Okay, let me rewrite the question, which is 3x squared plus 8xy plus 4y squared. Now, the technique is to use product and sum. So we're looking for two numbers p and q, whose product should be how much? Well, whose product should be 3 times the constant. We'll treat the other term as a constant. That's the trick. That means 3 times 4y squared. So what you get here is 12y squared. So we're looking for a product of 12y squared. And what sum are we looking for? We're looking for sum for the coefficient of x. Now coefficient of x is 8y. Does make sense to you? Correct? That is how you have to look at it. So now, how do you get 12y squared? Combination of 12 is 4 times 3, which will give you 7. 6 times 2 will give you 8. So we'll split this into 6 and 2. How about y squared? You have to take 6y and 2y. That is the trick. Perfect. So we'll take 6y and 2y, which when combined will give you 8y, and that works. So now we can write this as 3x squared plus 6xy plus 2xy plus 4y squared. Now the technique is exactly what we learned before. We can factor from the first two terms 3x, which will give us x plus 2y. In the next two terms, we can factor 2y, and that gives us x plus 2y. Perfect. Now x plus 2y is a common factor. We're left with 3x plus 2y. Do you see that? So that is how we can factor it. So I'd like you to go through this once again. Try to understand what really happened when we had two variables x and y. So critical step here is to note that we have to include y. Perfect? I hope that makes sense. Last three questions for you. Question number 8. Determine the expression for the perimeter of a square with the area 9x square plus 30xy plus 25. This is y square. Okay, so 35, 25y square. Basically, we are given the area of a square, right? So what we need to figure out is what is the expression for length and what is the expression for width. Of course, both will be equal. That is what we expect since we are given this to be n square. Let's figure it out. So the question is to factor 9x square plus 30xy plus 25y square. Why are we factoring? Well, this is the area given to us and we know area is length into width. Since area is the product of length and width, we'll convert sum into length and width. Is that clear to you? Perfect. Okay. Now, how do we find sum and product? These are pretty big numbers. Okay, so we'll have to do trial and error. So one of the numbers, the product of P and Q is 9 and 25 and y square is 9 times 25 times y square and the sum of P and Q is basically equal to 30y. Now, what numbers could you really get to get 30 as the sum? Well, here is a neat technique to do with bigger numbers. Let me write down here 9 times 25. So if I write 9 times 25, let's write down 9 times 25 here. Let's look into the factors. 25 factors are 5 and 5. 9 factors are 3 and 3. We have to look for a combination which could give you 30, right? So how can you get 30? 15 and 15 can give you 30. And when you multiply, you get the same term. So the magic number P and Q is 15 plus 15 or product of 15s. Does make sense to you? So that is your magic number. So we'll use that to factor. So we have the first term which is 9x squared plus 30x will be written as 15xy plus 15xy. The last term here is 25y square. What is common between the first two terms? Well, 3x is common. So we can take 3x common. We are left with 3x plus 15 divided by 3 is 5. So 5y. In this case, we can take 5y common. So if you take 5y common, you are left with 3x plus 5y. Now you can see that 3x plus 5y is common factor. And the ones which are their coefficients are also 3x plus 5y. So the result will be a perfect square, which is 3x plus 5y whole square. Now that means what? That means that each side is 3x plus 5y. What do we need to find? We need to find the perimeter. Perimeter is 4 times this. So let's write down the perimeter as 4 times 3x plus 5y. Does it make sense to you? So that becomes the perimeter for the given square. We'll just write units since no units are given to us. Now here is the last question, question number 10. List the integers such that 2x squared minus 2x minus 12 is divisible by 14. You can pause the video, answer the question, and then look into my suggestions. When we say that integers divisible by 14, it means it should be divisible by 2 and 7, right? So that is what it means. So those should be the factors also. Now let's look into what is given to us. we are given a trinomial which is 2x squared minus 2x minus 12. You can group factor 2, you're left with x squared minus x minus 6. Now that can be factored. Minus 6 will give you product of 3 and 2. So we are looking for two terms p and q whose product should be minus 6. So we could take as 3 and 2 minus 3 and plus 2, and the sum is minus 1, which works, correct? So we can say x minus 3 times x plus 2. So that becomes the factor. Since we're looking for divisibility by 14, we're looking for two factors, 2 and 7. We already have 2 with us, clear? So we are only now looking for 7. So we can equate this to 7 and find possible values of x. So let's figure this out. So we can write x minus 3 equals to 7, which will give us x equals to 7 plus 3, which is 10. Or x plus 2 equals to 7. That will give us x equals to 7 minus 2, which is 5. And therefore, we get two answers for this. The answers are x is equal to 10 or it is equal to 5, right? So both the answers are correct answers. That is how we are going to solve it. So we come to an end to this quadratic expressions. I hope you understand and appreciate what we have done to understand trinomials factoring. We took the form ax squared plus bx plus c, modeled it with the help of rectangular tiles, algebra tiles. We break up the middle term to really factor the trinomials. That breakup is done with the help of sum and product. We had few examples where common factor could be taken. We also came across a situation where we had two variables x and y, and then we had an extended question where we figured out how to get a part as a product of 14, for example. I hope you find it interesting and useful. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.